In this video, I'm going to talk about finding the area of a sector of a circle. So to start off, we have our circle here, and I'm going to cut a sector out of it with angle theta. This r just represents the radius of the circle. Alright, now I'm going to shade in the regions, and we need to figure out what fraction of the circle this part takes up. To do that, we're going to use the angle values, and we're going to represent them using these dashed lines. So over on the left here, you can see that the blue dashed line is 2 pi, or 360 degrees, and theta is our unknown angle. Next step is to use the area of a circle formula, which is pi r squared. So to find the area of just the red part, we need to multiply this formula by the fraction of theta to 2 pi. So let's do that at the bottom. When we do this, we can cancel out the pi's, and we are just left with r squared theta over 2. In the next section, we're going to look at a couple of practice problems. Alright, for our first problem, we have a circle here with a radius of 10, and we have theta is equal to pi over 6, or 30 degrees. So to start off, we're going to write out our formula. Area is equal to r squared theta over 2. And then we're just going to plug some stuff in. R is 10, so this is going to be 10 squared times pi over 6. And for this formula, we want theta in radians, so it's already there, that's good, over 2. Next step, we're going to say 10 squared is 100 times pi over 6. Make that a little neater. Pi over 6, then all over 2. We can take out the 2 from here, so that's 50. And then we'll take out another 2 from here, so that's 3, and this is going to become 25. So our answer is 25 pi over 3, and it's going to be units squared. We can do a gut check to see if our answer is in the right area by first figuring out how many times theta can go into 2 pi. So 2 pi is 360 degrees, and we want to divide it by theta, pi over 6. When we do this, this will become 2 pi times 6 over pi. Pi is going to cancel, and this is going to be 12. So theta can go into the full circle 12 times. Now, let's figure out what the area of the full circle is using pi r squared equals pi times 10 squared equals 100 pi. Okay, now we're going to take this 12 and multiply it by our sector area. So we have 25 pi over 3 times 12. And so I'm going to take a 3 out of here and a 4. This becomes a 4. And so 4 times 25 is equal to 100 pi. And so that matches up with the area of the full circle. In this problem, we have a circle with a radius of 4 meters and an angle theta equal to 60 degrees. So like I said before, for the area angle that we derived, we need theta to be in radians. So let's write out the formula, r squared theta times 2. Since we want radians, we need to convert this degrees into radians. How we can do that is we basically just tack on a conversion term here, pi over 180, to our formula. Just connect that. And then we can plug in everything as usual. This is going to be 4 meters squared times 60 degrees times pi over 360. Then we can take a 60 out of this. This becomes 6. And then, let's see, we have 16 meters squared times pi over 6. Let's pull a 2 out of each of these. So this becomes 3, and this becomes 8. And area is equal to 8 pi over 3 meters squared.